The first lesson that we're going to do today has a lot of new terminology. So that's what we're going to be focused on, terminology. So it's called the characteristic of a function. So even if you took grade 10 applied or grade 10 academic math, it doesn't matter. You probably don't know what a function is. So that's going to be the main goal of today's lesson. Figure out, okay, what's a function? So to figure out what's a function, we actually have to learn a couple other terminologies. The first is a relation. So a relation is just a set of ordered pairs. So here we have, for example, here we have a set, and then we have a bunch of ordered pairs, right? Here's a one pair, 1, 2, another pair, 5, 3, another pair, 9, 4, right? That's a set of ordered pairs, and so we call that a relation. And there's different graphical ways that you can show a relation. This one is called a mapping diagram. And so your first set, like 1, 5, 9, and 7, you would write here. But of course, you wouldn't write 1, 5, 9, 7. Notice the 7 comes first, right? You're going to write smallest to largest in that order. Okay? And then again over here, you'd write 2, 3, 4, 1, but again, in order from smallest to largest. And then you connect them. So for example, this pair is 1, 2. So you connect 1 with an arrow to 2. Right? 5 and 3, you connect 5 to 3. And so on. That's called a mapping diagram. Table of values is probably the one most of you are the most familiar with. Right? So your first number in your pair is your x values, and your second number in your pair is your y values. Okay, I put the x values in increasing order from small to large, but of course you can't do that with your y values because your y value must properly match with their corresponding x values. So example, 1 and 3, 1 and 3, 3 and 2, 3 and 2. Okay, and lastly you have a scatter plot. So for a scatter plot, again, we're probably have used to this or have seen it at least. We have our x-axis and our y-axis, and we just plot our pairs, our points. So 1 and 4 would be here. Okay, so 1 is x, 4 is y. There's your first point. Okay. 3 and 2, so 3 and 2 is your next point. 5 and 4, and then 3 and 1. Okay, so these are three different graphical ways that we can show a relation. Let me just pause it there. All right, so the next couple bits of terminology that I want to go over, which we are going to use a lot in every unit in this course, are domain and range. Okay, they sound a bit scary, but in reality, domain, right, is all of your x values in your relation or your set, right? And range is all of your y values, right, for all of your pairs. Okay, so for example, with example A, okay, so that's this one, example A, right, your domain would be all of your x values. In this case, we have 1, 5, 7, and 9. So we would just write 1, 5, 7, and 9, and your range would be 1, 2, 3, 4, right? All your y values. 1, 2, 3, 4. And we do write that in order from smallest to greatest. We don't need to match them like we would a table of values. Okay, because they're written completely separate. First your domain, then your range. So for example, B, our domain, again, all of our x values, we have 1, 3, 4, and 6. And all of our y values, or our range, here we have 3, 2, 2, and 5. So we're going to write it smallest to biggest. So that's a 2 we're going to start with. And even though we have two values of 2, we don't need to write it twice. Right? Just once. So 2, 3, and 5. And the reason why we do that is we simply say for our range or for our y values, one possible y value is 2. Right? We don't have to say one possible y value is 2 and another possible y value is 2. And there's no need to repeat yourself there. So we only write it once. And for our last example, when we did our scatter plot, again, your domain will be all your x values. So you look along your x-axis, and we have 1. Here we have 3. Again, we don't need to write it twice. And then 5. So 1, 3, and 5. Similarly, we can look along for our range along our y-axis. We have 1, 2, and 4. So we're going to write 1, 2, and 4. And those are our domain and ranges for each of our relations. Okay, so a function can be initially complicated, but it's actually not too bad. So let me slowly go over the definition, and then I'll explain it to you in a couple different ways. So a function is a relation. So that's an important thing. So all functions are relations. But, very important, not all relations are functions. So let's find out why. So a function is a relation in which each value in the domain, so each domain value, corresponds to exactly one element in the range. Just one. You can't have a domain correspond to 2 elements in ranges or more. Okay, so you can think of it as for each x value, there's only one y value, not more than that. The other way, vice versa, is possible. You can have multiple x values for any y value, but you cannot have multiple y values for any x values. So let me go over an example to see exactly what I mean here. So here I have the examples A and B are functions. So let's go back up to examples A and B. So example A, notice that for any value in our domain, it only corresponds to one value in our range. So that's a function. Example B, again, same thing. For any x value, it only corresponds to one y value. Example C, something weird's happening. Not quite so. So I'm going to take example C, and I'm going to show, redraw it as a mapping diagram. So looking at our points, we have, for example, 1 and 4. Well, actually, let's just look at our domains. For our domains, we have 1, 3, 5. So I'm going to write 1, 3, and 5. And our ranges 1, 2, and 4. Okay, so 1, 2, and 4. Okay. Now, according to our relation here, 1 goes with 4. Okay, so let's match 1 with 4. Okay, I'm not going to keep moving the page up and down, but the next one is 3 matching with 2. So 3 matches with 2. So far, so good. Then the next one, 5 matches with 4. And even there, that's okay. So we have 2 range values, or 2 y values, which is fine. You can have two different y values as long as their x values are different. Here's where the problem comes in. Our last one is 3 and 1, like this. Meaning, for this x value, it has 2 possible y values. That is not in the definition for a function. So this is not a function. Okay, you can have 2 different x values have the same y values, like both 1 is 4 and 5 is 4, but you cannot have one x value have multiple y values. Okay, so that's when you have a function or not a function. All right, so looking at a mapping diagram can help see if something is a function or not, but I think the easiest way to help see if something is a function or not is to look at a scatter plot. So what do I mean by that? I'm going to go over to the next page. So it says an easy way of determining whether or not a relation is a function is to use its graph and something we call the vertical line test. So the vertical line test states that a relation is a function if you can draw a vertical line through only one point. So let me grab a ruler and let me show you what I mean. So this first one, if I hold the ruler vertically and I move it across the x-axis, right, the place where the function, or this, well, I just said it's a function, the place where this graph, this parabola, touches the ruler should only happen in one spot. So you can see right now it's touching the ruler here. As I move it over, the place it's touching the ruler is getting lower, lower, down here. As I keep going, it only touches the ruler in one spot. If that happens, then you're good. This passes the vertical line test, and therefore it is a function. We look at the next example. As I move over, right, you can probably see what's going to happen. Suddenly, this parabola is crossing my ruler, crossing my vertical line in two locations, here and here. Right? If that happens, you just failed that vertical line test. And therefore, that relation is not a function. So going back to the first page, okay, we saw with example C, when we wrote it as a mapping diagram, that it's not a function. But if we also look at this graph and we do our little vertical line test, I don't know what this would look like. It would look something like this. And as I move over, we're okay, we're okay, we're okay until we get here. At this point, it crosses at 2 points, therefore not a function. Okay, just pause there. All right, so far I've looked at two different parabolas, but what about other graphs? Are they functions? Like a straight line. Is a straight line a function? Well, we're going to do a little vertical line test. And as I go over, it looks like that line is only passing in 1 point. So yes, it passes the vertical line test. Therefore, is this relation a function? Oops, I said yes and I circled no. Yes, it passes the vertical line test, and therefore yes, it is a function. Okay. Now a straight line isn't always a function. If you had a vertical line, if you had a line that went straight up and down, then yeah, in that case it's not a function. But every other straight line is a function. And what about a sine function? Now sine functions we will look at in more detail in chapter 6. But are they functions? Again, if I do my vertical line test and I go over, it looks like it only ever passes that ruler in one spot. Okay. So yes, it passes the vertical line test, therefore yes, it is a function. Okay. Again, for the definition of a function, for any x value, we only have one corresponding y value. But the opposite is fine. I can do a horizontal test, and I can have that line pass any number of times I want. And infinite times even, it's fine. Right? To test if something's a function, you just do the vertical line test, like this. Okay? So I'm going to pause there.